Hi folks, so in this video what we're going to do is we're going to complete a couple of questions here based on the topic of transformation geometry and specifically the area under central symmetry. So it tells us here in the question we have to, just get my pencil, we have to use a central symmetry to move the objects below through points P. So you'll see here in central symmetry, and I'm going to go to this one here first, but in central symmetry, if I go up to the rocket here, you can see we have a series of points on the rocket. Okay. Now what I'm going to do is I'm going to break up the rocket into a simple structure here. Okay. I've kind of got this little irregular pentagon. Forget about the kind of two side struts and let's say where the fire will come out of the back of the rocket. I'm just going to focus on this, and this. So if I was to give those labels, because this is A, I'm just going to call this point here B. Then I've got C. I'm going to go up here to D, E, and F. So if I want to find B, C, D, E, and F under central symmetry, it's quite easy. All I need to do is connect B through P and extend it on. How do I find it? You take the distance with your compass from P to the point and mark it. Okay, quite easy. Now, the other thing I could have done was also just found this point out here, and I can see that B and C are also on that. So while I'm actually at it, I will actually find this one as well. Now that I think of it. So I will find that one as well up there. And I'm going to take the distance from P up to that point there. Mark it out. Just need to extend the line a little bit further. Okay, and what's helpful here is I know that point there connects to this point. So because they've already given me A, and you can see it actually goes through my point B, which is really helpful. So I've got point B there, which I'm going to call it B1. Now I want to find C, and C is on that line as well. So if I want to find C, C connects through B, P I should say, and that should be where my C is. But just to prove it, I will take my compass, mark the distance to C, and take the distance out. Yeah, quite happy with that. Now I've got C1. Now what I want to do is I want to find D and F. So if I want to find D from that point through P, somewhere along that line is going to be D. Take the distance with my compass from P to D, mark it out the opposite side. And I would always encourage people to label them as they go. So I found D. Now I want to find E. So this is the line for E there. Take the distance once again with our compass to there. That's E. And finally, F. So from F through P, going to be inside there. Take the distance from P to F and mark it in. Okay, and once again. So now I know B connects to F. I'll head in this line here completely. C connects to D. D connects out to E. And E to F. So there we go. Now the last points I want to get are just inside in here. So how do I find that point there on the same edge? It's quite simple. Now that point there is on the line connecting from B to F. So I've already got that line. So to find it then, without even having to use my compass, I would still have to go through P, and it's going to end up hitting right there. Right there. So that's one way we could find it. The other way you could find it is simply by taking the measurement. So let's take the edge from C. So C to D, which is this line here, C1 to D1. I could take the distance here, like that, and then come to the new position for C, and simply mark it that way as well. So just to show you different ways we could do. and find it. So now I've found that. Last little bit I want to find is this guy here at the back. So he's going to be down there somewhere. So take from there to there. Just need to extend it on a little bit. And then once again, take the distance from P to the point and mark it out. And simply then heavy that in. So that's our first object. Now, when you're doing a junior cert exam, they wouldn't be as complex as this, but it is good skills. So now what we're going to do is we're going to complete this little question here based on the arrow. I don't know if we have to bring that guy with it, so I'm just going to do the arrow. So you can see here they've already given us the top of the arrow and the new position of it. So let's say if I label the arrow, if that was B, let's say this point here was A, B, C. I'm going to call this point D and this point E. I'm just going to focus on those 5. So if I want to find A through P, extend it out. A is going to be out there along that line somewhere. Normal rules apply. Take your distance from P to the point you want to find. Mark it out the opposite side. There's A. Now I want to find C. Take the distance from C. Mark it out the opposite side. Take the distance from P to C. Make sure you're accurate when you're taking your measurements. There's the new position of C. Okay. Now I know, let's draw it in lightly here first, that that's the top of my arrow, A to B to C. There's my triangle. Now more than likely D and E are going to be down here because it will invert. So if I want to find E, I'm going to project out like that. Take the distance from P to E. Mark it out. I've now found a new position for E. Okay. And then take the distance, last one, from D. It's going to be out there somewhere. I want to find D. That's why you can see here, because these lines were so close together, it is good that we marked it previously. And I can see exactly which one it's on. Okay, so you can see here it goes like this. Now, what's important here is finding the 2 points in there. And the good thing about finding those 2 points, connecting from C to A, that point there and that point there, if I just go through P from either one of them, you could do it that way, and it'll cut right there, as you can see. And I could do the same with the other one. That's why we need a good sharp pencil. And the other one cuts here, and you can clearly see where I connect them down to. Right there. And right there. And there. And there is our arrow. But, as always, at the end of the question, try and heavy in our little details. I've got this guy. And there we go. So there is our arrow, and it's been inverted, under central symmetry. Now what we're going to do is we're going to complete this little one here based on the, looks kind of like a traffic cone. So to start this one here, I'm just going to focus on the rectangle. So I'm going to say if this is C, this is B, A, and D. So I'm just going to focus on the rectangle first. They've already given us the image of C, so I'm going to find D now. So if you don't have a good sharp pencil and good lead on your compass, accuracy in these can be quite hard. So take the distance to D, there's D. Now what I'm going to do, to A, take the distance from P to A, mark it out the opposite side, to A1, where I wrote my D there now was a poor choice, but it's okay. Take the distance from P to B now. and there's B. And straight away, let's connect them up. Now, you always try and keep the lines parallel. You can do a bit of sliding set squares here if you wanted. But there is our inverted rectangle, okay? Now what I want to do is I want to find this point and this point. So a really handy way of actually finding those, you could actually go from this point through P. You could also do this. Let's say if I take the distance from, it's going from A to D is the distance I'm taking, like that. But I'm going to take the distance to where the cone actually hits, so to there. Now remember, I'm taking the distance from A to where the cone hits. So I have to go up here. Now I'm going to put it on A and mark it where the cone hits. Now I'm going to take the distance from D to where the cone hits on the opposite side. So the last time I did it from A to where it hit down here, I can do it from D this time, just to show you that you can do it that way. So same thing, I put it on D this time and I'll mark it the opposite way. So really handy. I've now found that point and that point. Okay, and it just saves me the hassle if I wanted, because you can get little discrepancies. Now the last one I want to find is the top point. So somewhere along there, through P, extend it on. There we go. So I didn't give that a label. And now that I have that, and there we go. So there is my rectangle, my triangle. Okay, and lastly I'm missing is these lines here. So this one here, to find the closer one first, I'm going to find this one. That's going to hit right there. So just put a little mark on that, just for reference. I'll mark the next one. And finally, the top one. Now what I would do here is I can see the relationship. This line here is parallel with this line. So parallel with that line, bit of sliding set squares here, just in case our accuracy is a little bit off. Parallel. Once you have the points, look at the relationships, and there we go. So there is our 3 questions done. Okay, so those questions, guys, come from the World of Graphics textbook. 3 little nice questions based on central symmetry under the heading of transformation geometry. Hope you found those helpful. Okay.